Hello, today I'm going to go over the asteroid lecture. So we'll be talking about asteroids generally and a little bit about where we find them and some of their characteristics. So when we're talking about asteroids, really it's just a large collection of rocks, right? It's large rocks that are floating around the solar system. So asteroids can be found throughout our solar system. They can be found really in any part of the solar system. They are large rocks traveling through space and orbiting our sun. So they go into orbit around the sun just like the planets do. And a lot of these are conglomerations of rocks held together by a small amount of gravity. All right, we go down here, and what we're looking at is kind of the main area where we're going to find asteroids in among the planets anyways. So this is the asteroid belt. The asteroid belt is a high concentration of asteroids found between Mars, which is right here, and Jupiter, which is right there. And we're going to talk in another assignment later on about the asteroid belt in more detail, but you're going to see that there's groupings. There's this main body here, but then there's these other groups in orange, another group in green, and they're arranged like that for a very specific reason that has to do with Jupiter and its gravity. So evidence suggests that Jupiter's gravity caused the asteroid belt to be a failed planet. So this might have solidified into a planet, but it seems like Jupiter's gravity had an effect on that and didn't allow it to solidify into a planet. Okay, let's move on. Now, most of the asteroids that we're going to see kind of look like this, just kind of a lumpy chunk of rock, not necessarily spherical. Even though the asteroid belt looks like a dense cloud of rocks, most asteroids are over 1 million kilometers apart. So usually when we see an artist's representation of the asteroid belt, it looks like it's really thick cloud, just asteroids piled on top of each other. But in reality, they're very, very spread out. 1 million kilometers apart is pretty far. But when you map them on like a map of the solar system, it looks like they're really close. All right, now going down here, talking about the sizes of the asteroids that we find. While the asteroid belt does have large asteroids up to 1,000 kilometers in diameter, most of the asteroids are smaller than a football field. So there are exceptions, of course, where some of them are bigger, but the vast majority are going to be smaller than a football field. They become more numerous the smaller you get in size. So the smaller you go down into size, the more of those asteroids you're going to find, right? Where the vast majority, if you're comparing them by percentage, are even much smaller, 1 meter, 2 meters, 3 meters, very small pieces. All right, one more here. So what I have an image of here is planet Earth and our moon, and then Ceres. Now this is a pretty good approximation of actual size, right? This is the moon compared to our Earth, and that's about right. That's roughly the right size. And then Ceres is here. Ceres is the largest of the asteroid belt asteroids. And you can see that it kind of looks similar to the moon, actually. It is currently classified as a dwarf planet and has a distinct spherical shape. So it's big enough now where it looks like a sphere. Most of the asteroids start to lose that spherical shape as you get smaller. So most of the asteroids are lumpy and not spherical. This example is about a 60-kilometer long. So this asteroid's about 60 kilometers long and has its own tiny, right there, tiny satellite, about 1.5 kilometers asteroid. And it's the gravity of this larger asteroid that attracts the smaller one. So that smaller one orbits around it or with it. All right, hope this helps. Thanks.